Okay, so there's a lot of blanks on this first statement, but hopefully you guys can maybe piece it together. What do you think goes in the first blank?
Star.
A star is made mostly of, what do you think goes in the next blanks? Helium and hydrogen. And emits its own light through the process of what? Somebody said it. Yeah, nuclear fusion. Okay. Okay, and just in general, if I use whether I'm using it in science or not, if I say the word fusion, that means something's getting stuck or glued together. Okay, so nuclear fusion, what winds up happening is under crushing gravitational force, extremely high temperatures and pressures, hydrogen atoms are actually squished to the point that they fuse, creating heavier atomic nuclei in the form of helium, and that whole process releases a whole bunch of energy, okay, which is where the sun gets its energy and all the other stars. All right, next question. So a star is made of mostly hydrogen and helium. Well, Jupiter and Saturn are also made mostly of hydrogen and helium, but they're not stars. Why aren't Jupiter and Saturn stars? Anybody have a guess? Go ahead.
No.
Shh. One person at a time. Nope. They're not hot enough because they're not stars. But why aren't they stars? Think. Do what?
Because they're not burning.
Well, they're not burning because they're not stars. But why aren't they stars? They've got the same ingredients as the sun. Think. What's the difference? Do what? Well, it's not being fused together in Jupiter and Saturn, but there's a reason why it's not happening with Jupiter and Saturn. Think. What's the major difference? I've already told you that Jupiter and Saturn are made of basically the same ingredients as the sun. But why is Jupiter and Saturn, why are they planets and the sun is a star? Think. What's the major difference? No, it's not the orbit. Do what? No, it doesn't have to do with how close. Well, there's no nuclear fusion because they're not a star. But why aren't they a star? Think. What's the major difference? I've already told you that Jupiter and Saturn are similar to the sun in their ingredients. What's the major difference? I give up. Don't give up. Come on, think. I know that they're planets. Why are they planets and not a star?
We don't know.
Okay, y'all look at that poster over there. Do you see the big, teeny tiny slice of the sun at the top?
Yeah.
The 8 planets poster, right there in front of the lava lamp. Why are Jupiter and Saturn planets and not stars? Look at the relative sizes. They're not big enough. They don't have enough mass.
What?
All right, so nuclear fusion is only going to happen if you've got enough mass to create those crushing forces in the core of a star. Jupiter and Saturn just simply don't have enough mass. Everybody got it? Okay, you're going to need lessons 2 and 3, particularly lesson 3 for the next question. You actually wrote this in as you followed along with lesson 3. When a star is stable, what 2 forces are balanced? I'm looking around my room and I see basically no one with their lesson out. Find your lesson. Go look for this answer. All right, so the answer you should be able to find on the bottom of page 295 because you should have written it in as you did lesson 3. Okay. So we have that crushing force of gravity that's going to want to make a star kind of squeeze in and collapse in on itself. So it would be directed inward. But that force is balanced by this expansive force, which we get due to all of the energy being released. And when those two forces are balanced, we have a star that will shine and be stable for a long period of time.
We have to draw that.
I would. I mean, if I'm up here doing all the work for you, the least you can do is just copy down what I do. So, yes, please draw it. All right, the Hertzsprung-Russell diagram. Again, you should be referring to lesson 3. The Hertzsprung-Russell diagram is a graph that shows the relationship between what two variables, basically? Come on. All right, on page 300, you're looking at an example of the Hertzsprung-Russell diagram. What are the two variables that are graphed? What's one of them? Temperature, and what's the other one? Brightness. Okay. So it is a graph that shows you the relationship between temperature of a star and its brightness. Okay? Now, we talked a little bit about this yesterday when we did yesterday's Bellwork. Do y'all remember this, where I gave you those 6 terms and I asked you to sort them into 2 groups of 3? Those of you who are shaking your head, you were probably gone for band, so you need to take care of this. Okay, but I sorted those into 2 groups of 3. On my x-axis of this Hertzsprung-Russell diagram, I am going to put temperature. But what other things basically mean the same as temperature? What are the other things from yesterday's Bellwork? Color and spectral class. All right. What goes on the y-axis, guys? Brightness, magnitude, or luminosity. Which word is written just depends on, the person's preference who's making the graph. Because they all basically mean the same thing, don't they? Brightness, luminosity, magnitude. Okay? All right, what is this diagonal band called? Again, you may need to refer to lesson 3. That is called the main sequence. Excellent. Okay, guys, a star will spend most of its life, I guess you could say, on the main sequence. When a star is fusing hydrogen, really, really massive stars are bright and hot, and they get plotted up here because actually the x-axis runs from hot to cold, not the other way around. So really massive stars typically get plotted up here. Really small stars tend to be a lot cooler and dimmer, so they get plotted kind of down in here. A star about the size of the sun is sort of medium brightness, medium temperature, gets plotted here. But all of your stars that are fusing hydrogen and doing its thing, living its life, its brightness and temperature winds up getting them plotted somewhere on this diagonal usually, okay? It's only when a star is undergoing major changes towards the end of its life that it starts getting plotted somewhere else on the diagram. Okay, maybe it's a white dwarf, or maybe it's a supergiant or whatever, and it gets plotted elsewhere. So the main sequence, I want you to understand, is where stars spend most of their lives. Okay, and while a star is a main sequence star, what is that star doing to generate its energy? No. How do we generate the energy from a star? Yeah, while it's fusing hydrogen. At the end of its life, a star doesn't have a whole lot of hydrogen left, and it's got to do something else to generate its energy. And even though we're not really going to get into all of the what else that is, just understand that typically a star is plotted somewhere on that diagonal band while it is fusing hydrogen, while it's, kind of living it the main part of its life. Is everybody good? All right, so you need to finish this up. You need to make sure your name's on it, and then you need to put it in the box so that I can give you credit for your daily check-in.